Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Venus Bulge, Gravitational Waves and Hollow Planets. Now, in Article 347 entitled Gravity Wave on Venus Suggests Planet X Presence, I detailed how a gravitational wave was discovered on Venus in 2015, which has since reappeared many times, and that since the bulge remains in place in the same position with respect to the surface of the planet, that it has to be the result of Venus having captured or hosting a Planet X object or stellar core, and how this suggests that these objects attach themselves to solar system planets as well as to the sun. And here is the wave. It's the same image I showed in that article. As you can see, it remained in about the same position for 4 days. And that means that it stayed stationary with respect to the surface, because Venus's period of rotation is 116 days long. That's the planet itself. But the atmosphere has a rotational period of 4 days. So in 4 days it should have completed one whole rotation, and yet the wave remained stationary in it. Now, this revealed that this was a gravitational wave created by an object approaching the planet, although the Japanese scientists thought it was created by mountain ranges on Venus. I didn't think that would be possible, because otherwise it would have been happening for a very long time now. It was never observed before. So that's all detailed in that article 347. Now, there is something very interesting about the shape of the gravitational wave. It is not in the shape of a cone, as I have theorized in article 345. Hurricane Florence, tidal event and gravity waves. And in article 346 entitled Planet X reveals that gravity is a wave frozen in time. It is instead in the shape of a ring with a hollow on the inner side of the ring. This suggests that it produces a low and a high tide, but that the high tide is more pronounced than the low tide. This therefore suggests that the gravitational wave associated to the gravitational interaction has a central minimum, not a central maximum, and that the amplitude of the first maximum is higher than that of the central minimum. So this is how I did the gravitational wave before. I theorized it was like this, that it had a central maximum and then it had a first minimum. The hollow all around it would be the first minimum that would not be as high as the central maximum. So if you were looking at it from the top, this is what it would look like. It would have a central bulge, a central maximum. But from the wave on Venus, that does not seem to be the case. The wave pattern on Venus is different. It is wider along the vertical direction and is curved as if it is an outside ring, not a central maximum, on a circular diffraction pattern. Also, the depth of the troughs in the inner part of the ring seems less than on the outside, but its depth does not seem to be as high as the height of the crest of the wave. This indicates that the stationary gravitational wave pattern is more like what is shown here. So it looks like this water wave, which has a central minimum, it has a trough in the middle, but it's of lower amplitude than the first maximum and lower amplitude than the first minimum, generated by and it's generated by these, as you can see, these drops of water falling at the center. And on the right we see the Venus wave for comparison, and this is definitely not a central maximum. This is part of a ring around a as the central part of the wave. So it's more like this. And this trough, which is the first minimum, seems to actually be deeper than the central minimum. So this would suggest that stellar cores would generate a gravitational wave that looks more like this. A central hollow, the first maximum, which has a higher amplitude than that hollow, and a higher amplitude than the first minimum, which we see here. And this would create this high and low tide pattern on the surface of the ocean. Now, the object creating the wave pattern on Venus was most likely a little distance from the planet and on the left or night side of the planet, so that a line running through the center of the object would pass through the central minimum of the stationary circular wave pattern. So this is what we see here. This would be the stellar core. This would be the wave, and the wave actually would go all the way around the planet. It would not stop there. It would go all the way around. So in a front view, so if you were standing here, this is what you would see. You would see a ring on the surface of the planet. The radius of the gravitational wave ring will decrease as the stellar core approaches the planet and will eventually turn into a vortex. And this is what's illustrated here. So as the stellar core comes closer to the planet, the ring will be of a lesser radius. It will seem to get smaller, but the height of the wave will get higher. So this first minimum will seem to get taller. Until eventually the stellar core, when it's very close to the planet, this turns into a vortex. The central minimum explains why vortices always have an empty central space. The minimum in the center is all that is necessary to cause water to spiral around the central space, and it will thus occur without any need for magnetic field. In fact, any detectable magnetic field may in fact be due to the motion of the particles as a result of the symmetry of the gravitational wave. And here you can see vortices, water vortices. They'll always have a hole right through the center. The fact that gravity is a stationary wave, or a wave frozen in time with a central minimum, means that all massive celestial objects must have a central hollow space. Thus, all cores of planets or stars will have a central spherical hollow space in them. This is because any matter moving into this region will be repelled from that region and thus move away toward the region where gravity is again attractive. So this is what a stellar core that has not yet lost all its outer layers may look like. Well, a planet will be similar, except it will most likely have more material on the outside, but all these objects that have cores in them will have a central spherical hollow space in them due to the gravitational wave having the symmetry that it does. It always produces a hollow. So this would be the inner space. That would be the central minimum of the wave. This would be the first minimum. In between, there's the first maximum. And this would be the first minimum. In this case, it's still inside the material, the outer layers of the object. There's another minimum here. This one would be outside of the planet. Now, the minimums are positions where gravity reverses, but the reversals are never as strong as the regions of attraction. So that hollows on the surface of the ocean created by a tidal force, or the gravitational influence of a massive celestial object close to the surface of the Earth, are not as deep as the bulges. In conclusion, gravity appears to be a spherically symmetric wave frozen in time, or stationary with a central minimum. This suggests that all celestial objects with cores will have a central spherical hollow space inside them. This also explains why vortices have a hollow space in the center. This is the same reason why hurricanes and tornadoes have eyes, where there is no wind circulation. These all appear to be gravitational vortices. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.